Hello everyone, this is Bradley. So today this is a tutorial talking about this unfolding spiral animation on text. It can be used in other cases as well, depending on what you're actually doing. I think many different people have done this, but I cannot find a reference in geometrynodes. Although I think people really did that, just I couldn't find that. But anyway, we've discussed the kind of different approaches, procedural, non-procedural, semi-procedural, and so on. But today I'm going to only present one way that I think which is reasonable. So let's start. So here we in Blender, as always, I'm going to use the preset which you can download for free from the link in the description. So firstly, let's talk about the basic principle of this kind of animation. So we start with a spiral and you take the height to be 0, so everything is on a plane. And here I want you to realize the relationship between this kind of rotation, which is actually exerted on the end radius. Okay. So here we are going to reverse this end radius to make end radius into the center, so that when we decrease the rotations, it goes the other way around. Okay. Another thing we can do is try to trim the end so that it's trimmed the end. Okay. The reason this is so important is because we're going to fix this start radius end. Okay. So we need to reset the position somehow. So in this case, we have to do this a little bit manually. So for example, you just -1 because the start radius is -1, and we're going to rotate this thing to be up. So I think it's just Y, something like that. So we have this shape. I would like to make it aligned on x-axis. It's just a personal preference. You do not necessarily follow what I'm doing. As long as it's kind of erecting like this kind of shape, I will be just satisfied. Okay. Next thing I would like to do is to create another spline, which is basically kind of extension, or actually, yeah, whatever. So let's take a join geometry, and let's use a curved linear, which is basically just a curved line. Actually, I do not think a curved linear is very important, but just to give you kind of idea. So in this curved linear, I'm just going to turn on this value. So this curved linear, by default, it's just a centered line. I'm not going to make it centered, so it's just extending on that direction. Okay. So in this case, you can actually see there are two kinds of spiral, which also means if I move this and the spiral, you feel like they're connected together. So this is kind of illusionary, but this is basically the principle of what we are trying to do. Okay, so here what I'm trying to do is to make a curve sample, and let's take a transform, another transform, because I do not want to touch this kind of rotations. Okay, and I'm going to sample this curve to manipulate all this kind of position and so on. So right now, this is what we're getting, and I'm going to use the factor 1. You do see this kind of rotation issue because we rotated that wrongly. Okay, so now we have this factor that moves this spiral, okay. And we can use the same factor that affects the end trim. So you realize there's a mass involved, so we just make the subtraction of 1 and take this kind of value and plug into the end. So right now, it does not really happen. It does not really happen. Right now, oh yes, we also need to take the join geometry to review the original curve linear, and we also need to trim it. So we have this kind of a single parameter control 3 parts. So now you feel, yeah, this is how it works. And you do realize there's some issue, like this is a kind of, something is wrong, but you get a kind of idea. As long as you get a kind of idea, it just be fine. Okay. Because you can always make it more kind of procedural by turning this rotation. I believe you can also manipulate it more realistically to match the length of this kind of two curve, but that's another story which I'm not going to really touch at this specific moment. But just to know that this is kind of idea how you how you kind of fake any effect of this unfolding spiral. Okay. So after knowing this basic setup, we can move on to a more advanced example, more complex curves or even multiple curves. Okay, so I'm just going to duplicate this node tree. You do not necessarily do that, but I think the last setup is very inspiring as a good example. Okay, so now we are moving to string to curves so that we generate multiple curves. Basically, you type in text and it will make the text into curves. So let's just type in Blender and make it center and middle alignment. There is an issue that I've mentioned in my follow spline tutorial that the sample curve node is good to work with a single curve. But in this case, when you have curve instances, it's not very good to work. Actually, it doesn't work at all. It's just work very badly, not anywhere desired. So we have to use another method, which is called a trim curve. But if you just plug the trim curve, it does not really work because the trim curve does not work for cyclic curve. The workaround has been suggested just recently in my other tutorial in which you're using this preset of reset spline cyclic. So now you can start to trim it, which is basically making the spline uncyclic while keeping its shape. This kind of improvement was for the text is also suggested by a user in Discord server recently. So thanks for his inspiration because the mathematical function is very nice. Okay. So here we just use another preset which is called follow spline. So this follow spline is basically trim curves inside because it was the gold standard method. And by turning this loop into one, it means you loop start and the end. Then you can actually loop infinitely with this reset spline cyclic. Okay, so after doing all this, we just do this kind of instancing. So we remove this join geometry and transform. We appoint the instance it. So this spiral will be the stuff that we're instancing. Okay, so right now we can remove all this kind of trim cyclic because we do not need them for the moment. We just need to make sure we have this spiral which has been already been transformed, have this kind of alignment, and you plug this geometry into the instance. Okay. So immediately you have seen this, and we can have a more correct alignment with this kind of rotation. If it's not correct, then you can either manipulate this kind of rotations here, or you can just take a Euler rotate Euler, and the local, so that you're trying to make that erecting itself. I think this is kind of idea. Let's take a join geometry so that I can see the original spline. Okay, so this is how it looks. Seems kind of not okay. So we rotate it, rotate another 90 degrees. So we can make sure that the alignment is correct on the tangent of our curves. Okay. And we also need to deal with this kind of scales, then just scale them down to match roughly this kind of text objects. Here I realize these kind of alignments are still not really correct because there is some issue. I think there's recently a bug report talking about this kind of tangent interpolation. So what we do here is just to resample the curve a little bit more, and you can see it becomes much more accurate once we increase the resample count. So now it becomes basically perfect. Okay, but it also makes the kind of movements more, how should I say, more sharp, as you're seeing from the original animation. But this is kind of limitation of the methods. It's kind of expected, so there's nothing I can really do. Okay, so once we have finished this, we just try to start with our actual animation. Previously, in our previous node tree, as you remember, we're dealing with all this kind of trim, and movement, which is used by this sample curve. So in this new node tree, we're going to do exactly the same with trim. Okay, so we need to basically two trim curve on the up, trim curve in below, and to enable trim curve for different instances, we need to realize the instances. Okay. up to now we have basically finished this animation. Just to know, this is completely procedural setup. It does not necessarily start with this string to curves. You can even draw curves or whatever stuff. It's just an example. Okay. At the end, I would like to add a little bit more tweaks to that, because currently you realize everything we started with the same spiral, and this is not really realistic. Okay, because at the end, for these kind of different splines, we actually have different lengths. So it's not really realistic, although probably no one will actually complain. So here, what I would like to do is I'm going to use the increase the rotation, so I'm increasing the length of them, and probably decrease the end radius. So it's still the same, but we're going to do things a little bit differently. Instead of trimming by factors, which is from 0 to 1, I'm going to trim based on the length. Okay. So right now you can see the length is coming from the maximum length. I do not know the maximum length, and it comes down to 0. Okay. So the maximum length can be derived using this spline length, and I want the spline length given from each splines from our text. Okay. So we need a transfer attribute. Okay. And basically you plug these geometries into, and let's use the index. Choose the spline domain so we can take the spline length for each spline, which will be transferred to each of our spiral. And we basically take a multiply of this effect and plug that to the end. Immediately we can see there is this difference of spiral being generated. In reality, it's actually just a different trim on this kind of spiral of the same length. And then you play this animation, it's basically the same, but it gives you kind of more realism, because they end up having different lengths of a spiral. Okay. Of course, it can be more procedural, because right now it's still not necessarily accurate if the lengths aren't the same, but no one will actually figure out the difference. So basically this is it. You just try to play around all this kind of value or other things. At the end, for this kind of spline to show in the render, otherwise you probably won't see anything after you disable this kind of overlay. So you need to give them some mesh. So you take a bevel curve. Okay. Instead of using a circular curves, I'm going to use a kind of linear spline. So let's take a curve linear and add a custom bevel. Then immediately it becomes kind of linear. You can also add a solidify modifier, just to make sure that these are not the instances. Yes, these are not the instances. So you can use the solidify modifier to give them some thickness, and you can even bevel that, and so on and so forth. So finally, it's just kind of artistic tweak about how it has been going, but you do realize there is some issue with these kind of gaps. Okay. In reality, I don't think people will actually care about these gaps, because they probably won't really aware of that when you look far away of this entire setup. But if you really would like to resolve that, then you can potentially plug a merge by distance. The issue of merge by distance is it does not work for curves, so you will have a warning. It says it doesn't support it. Maybe it will support in the future, but now it doesn't. So in this case, you can also increase the distance, and you will find it rather becomes an issue instead of helping anything. So perhaps you can tweak some more values, for example, dealing with the parameter to reduce these kind of gaps and so on. So for example, let's just add 0.001, 03. Then you try to connect them. But there are other issues but I'm not going to deal with that honestly, because I don't think this is a very prominent problem. Just to know that I would like to keep this count to be low, otherwise you will actually see how this count is actually effective to the subdivision. So it's kind of unnecessary. So after achieving something like this, I think this is enough. Finally, it's just about the shadings. You just take a set material and doing all sorts of other things. But basically this is it. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye bye.